Hi everyone, in this video we're going to learn how we can create this type of painted grain effects directly inside of Blender using the Nexus tool from Insidium. I want to give credit to Paul Esteves on this one. He created this effect on Houdini, but for the purpose of our video, we're going to see how we can achieve the same result and recreate the same process using Blender and Nexus. So we can start by deleting the starting scene, and in the Nexus tab, I'm going to add a Nexus emitter. By default, I have this square plane that emits in a straight line. I will keep this emitter, but in the minus z axis, and I want to scale it a little bit in a more rectangular shape of 2:4, which will give me this 1:2 ratio that can fit my screen. I don't want it to emit by rate, just like this. I want it to emit in a shot of particle. So as you can see, it now emits down because I used minus z axis, and it emits only once because I have set it to shot. I want this shot to last 5 frames. So during 5 frames, I'm going to emit particles, and I can just crank the count off to 10,000. So I can have this wide surface of particle, just like that. I can also delete that starting speed that give the straight line movement. So now I have a flat surface of particle, and I want to reduce the radius a little bit to 0.01. Great. I can display these particles as spheres, not as points. So now I can see them as the grains that I want to in the result. As you can see, they collide with each other. They are not believing like physics geometry. So I need to add a Nexus push just right here. I want to set the radius to for the distance to particle radius, and I can just crank up the strength to 100%. So now my particles have their own space and don't collide within each other. In order to avoid inside collision with my particles, I also want to add a Nexus scale, which will have to affect to scale my particle during time from a radius to 0 to 0.1, which is way too big. I'm going to set the same scale as my emitter, which is 0.01. And I want to scale it not during 2 frame, but start to end frame. I want it to be 8. So now, during 8 frame, my particles are scaling from 0 to 0.01. The next step is to add a collision to this particle surface, because I want it to be more like a pool of particle. So I can add a cube, and that cube I want to scale it by 2 on the y-axis to fit my emitter. I want to scale it down on the z-axis to make it a little bit skinnier. And I also want to delete that top face, just like that. I will give it some kind of a V shape. So I'm selecting the top edge loop, scale it. So now I have this V shape, and I just scale it up overall a little bit so it doesn't collide with my emitter on the border. I want to have a little space. I can also bring my collider up so my emitter is more on the bottom of my collider. If I add now a Nexus collider, select my cube and play the animation, nothing happens. Well, almost, but as you can see, it go through. That is because by default, the normals of my collision is set to outside. And if you remember, I deleted my top face, but this is inside of my cube. So I need to set my normal to any, or inside works in this case, but it's better to set it to any. I want to get rid of that bounce, and I want to add full friction so my particles just stick to the surface. Great. So now it collides with the border and they just push each other to win back that thickness of particles, just like a pool. If I hide my collider, you can see I have a little bit of thickness around here. I can also, in my scale, add variation into this scale of radius. So now I have bigs and small particles, which is much more pleasant to look at, more satisfying. Next, I want to set my drawing setup. So I want basically drawing through a line. I want a path that allows me to draw those particles, to paint them. So I need to add a Bezier curve. I can rotate it 90 degrees, and I can just set my start outside that frame and the end on the other side. I can also subdivide it to add another point in the center, which will allow me to have that nice path here. So I can definitely draw the path I want. This is just for the purpose of the example. Great. I can add a null that will be used as a parent for any elements that we need to animate. And this null, I can add a constraint of follow path and select my curve into the target. So now if I move the offsets, my empty is going to follow my Bezier curve. So at the start of my animation, I'm going to set it to 0, add a keyframe, and at the end, I want to set it to the edge of my path, or basically minus 100. Set a keyframe, and I can also scale the display size a little bit so it doesn't make it overwhelming in the viewport. So anything I want to animate along this path will be parented to this empty. This is going to simplify the scene a lot. So I have this movement for now. In order to paint those particles, I want to add an NX question. So NX question. The NX question node allows us to put some conditions into our simulation. So I can click the plus and add a question. If something happened, then I want to add an action. So if something happened, do the action. So here by default, we have if the age is greater than 0, set the color to yellow, which have two effects: to set everything to yellow because everything is more than 0 frame old. So we actually want to set the if. I want to change the age by field. So if particle is inside my field, you can change here the color, do the action. But I don't have any field for now. So into the fall off tab of my next question, I can now add a fall off, which is basically a field. And I want to change the default box by a sphere. And I can set this sphere to be at the same place than my empty. I can then select my empty and parent my fall off to the empty. So now my fall off is following my path, which also have for effects to do the action on its way. So here in my next question, if this particle is inside my field, I'm going to do the action, and the action is still to set color. But we don't only want to set the color, and this is a flat color. This is not really what we want. And in order to create the action that we want, we need to not use here set color, but I want to set those particles inside another group. I want to isolate them. So in order to change the group, we need to have groups because we don't have any right now. So I can go inside my emitter. Inside the group tab, I can add some groups. So I can add a first group, and it created an NX group. I can name it group 01. And you can see I have a bunch of parameters that are attributes for my group. These attributes are overriding my emitter. So you can see if I play the animation, bunch of things happened. It's not what I chose at the first place, because first of all, we have points and not sphere anymore, because we display our group as a point. So I want to set it as sphere, and I want to delete that starting speed because it's projecting my particle downsize. It adds a default speed that we don't have in our emitter. I also want to decrease that radius to 0.01, the same I've used. I want to recreate the parameters that I've used inside my emitter, basically. So now I have the same thing, but I only have one group. So go back into my emitter, and I want to create another group that I will name group 02. I want to set it to pink. Delete the speed, set it to display as sphere, and reduce the radius. So now if I play, I have both of my groups, but that's still not what I want. I want to start at my green group, the 01, and I want to change with my fall off to the pink group, to the group 2. So inside my emitter, I will change the random mode here to first group only, because by default, particles are set in group 1 and 2 randomly, just like this. And I want to set it to first group only. So now we start at first group. Great. And inside my next question, I want to set the action to set group and select my group 2. And if I play my animation, here you can see that the color doesn't change, and it's normal because the color of the group is set only at birth. And to change the color of our particle, we need to do this with an NX color node because otherwise we could not animate it. So basically, the color is going to override every color of the scene. And by default, we have a gradient parameter by speed, which means particles that are going fast are going to be white and slow is going to be blue. If we change this speed parameter by fall off, once again, I can then go into the fall off tab of my Nexus color and select my fall off, my spherical fall off that I've created for my NX question. This is the same. So now my fall off is now painting my particles. The thing is, once it's too far, it's coloring back to the default value. That's not what I want. So let me start by changing the color. So I want to edit that gradient here, go to the preset and select the monochrome grayscale, which allows me to have a nice black to white gradient. And then I can change the blend mode, which will allow me to not color it normally, but to add the color to the base color of my particle. So now I have my green back because first my default particle, my group 1, is green and my NX color is adding color on top of it. But remember, I'm adding black, which is basically 0. I don't add anything. But if I do add white at my fall off, this is going to add the white on top of my base color. So now I'm basically painting my grains with white color. Nice. So in order to get back my black to white grayscale, I want to change the green of my group 1 to black. So now I have a pretty nice grayscale. I also want to affect this group, not only to be white, but I want it to scale up. I want it to take more space. I want to make a flow of this coloring particle. So I'm going to add a Nexus scale, another one. So I'm going to name the first one O1 and the one I just created, Nexus scale O2. I can bring it down actually. And I want to change the radius of my particle, but by affecting here in the group affecting tab, I want to affect my group 2. So once my particle is affected to group 2, it's going to change its radius to 0 to 0.1 over 2 frame. I want to change that. I want to set my starting radius to 0.1. This is my basic scale here, my group 1 scale actually. And I want the radius end to be a little bit bigger, like 0.03. And I also want to set it to 8 frame, a little bit longer to take. So now I have this very smooth scaling of my group 2. Once you're in group 2, you're going to take 8 frame to scale by 3. And we can add variation to it, which will allow us to have big and small spheres. So I can decrease this a little bit of 0.2. This is a little bit too big. And this looks nice. Great. So you can see I have very small spheres and very big spheres. What I can do is allowing myself to get more control over that fall off. Basically, I want another fall off for my color than my scale, because I want to be able to control my gradient of color differently than my gradient of scale. So I going back to first frame, and I'm going to duplicate this fall off here. So now I have a second one right on top. I can scale down a little bit this one here. I'm set it to 0.4. I want a very small orange sphere, and I can scale this up. So the more distance I have between the orange and the blue circle, the more gradient I'm gonna have. It's going to be more smooth transition, smoother transition. I can also add a fall off spline, so I wanna something pretty sharp for this one. I'm going to name this one fall off color, and rename the other one fall off scale. And for the other one, I first want something also a little bit smaller, and yeah, I'm going to scale it up a little bit. So I have pretty much the same center, but I have a gradient that I have another gradient that I can control. It is smoother for the color than the scale. You can also add a little bit of spline here, smoother than the color. So now in the Nexus scale 02, if I go to fall off, I want to add my scale fall off, and into color fall off, I want to add here, I have the scale, I want to remove it and add the color instead. So now you can see that my color is way smoother than my scale. But as you can see, it grows down after the fall off is passed. So I want to change the timing particle age to fall off here. So now, yeah, it basically keeps the second scale forever. So now that we have something that looks great on the paper, I want to add a global cohesion between my particles that will make them behave a lot more like a fluid, something that will make it way smooth on the animation. So in order to do that, I want to add a Nexus fluid, and I want to set it to APEC. So I have this domain that limits the world where my liquid is going to simulate. I'm going to set the bounds around my my emitter, so I can set it roughly around 3 by 5 by 1. It should be enough for my simulation. Can even set it like by 2 if I want to be sure. And if I simulate, you can see that multiple things happened. First of all, I have my liquid simulation. It behaves a lot more like a liquid, but it does scale downside, and it's kind of a bug for now, I guess. But this is due to the fact that my cube here, my limits are colliding on the inside, Here, remember, we set the bounds to any on the start of the video. So I need to invert that cube in order to make it face on the outside normal. I'm going to select my top loop and invert it just like this. Move it down along the Z axis, and then I'm going to rotate my bounds upside down and bringing back once again in order to make it so that the emitter is right on the bottom inside. So now if I play my animation, it does scale perfectly. Yeah, so this is kind of an issue with that colliding, but this is a way to fix it. Just invert your normal, I guess. So as you can see, it now does move like a fluid. But the only movement we have is still the scale of our particle. So we can, first of all, set a little bit of viscosity and surface tension, just a bit. So the liquid movement will be more unified. And if I go into display and I display base only, you can see this grid is my voxel size. And this is the resolution of my fluid simulation. So if I want to increase it, I need to decrease this value, like 0.5, for example, 0.05, for example. So now I have a more defined grid, more defined voxel. And this is to give me a simulation that's more precise and more defined. If you want it to be dragged like an object is painting this manually, we need to add another collider. And for this collider, we're going to use here in mesh, we're going to create a cone, and that cone, I'm going to rotate it upside down, scale it down quite a bit. And I also want to place it around my empty and parent it to my empty. So now it will also follow my curve. Great. And from now we can just add this cone to the collider. I can set the bounds a little bit higher and set a little bit of friction so it doesn't completely slide along it. And now we have something that drags my particle along the movement of my curve, and this is creating this vorticity inside my liquid. If I hide my cone, this is what I get. In order to make this more defined, we can also jump into the emitter. We can add more particle, way more. This is a little bit too much. And we can reduce the radius of a particle. So now we only have a lot more of them, but this is going to be too thick. As you can see, if I scale them now, this is just too big for that much particles. So what I need to do is jump into my group 1 and decrease the radius of my first particles. So I can just here scale them down. So now my particle are going to be at birth at 0.005 meter of radius. In my scale 1, I am scaling them from 0 to 0.1. I can also decrease this. And in my scale 2, I'm going to adjust my starting point to also a more defined radius end. So now what I should get is a lot more and smaller particles. So when it does scale, it's actually a lot more defined, and we have a lot more quality in our animation. So of course, it is to take a longer time to simulate, but we're going to have a much greater looking result in our simulation. Now, if I want to render this, I need to make those points real geometry. Because remember, in my emitter, I am only displaying those particles as spheres. I can uncheck this show particle. This will hide everything, but I can export it as point cloud instead. So here in my emitter, inside parented to my emitter, I have a point cloud that has been created. So if I play here my animation, you can see that my points have been replaced by geometry points. And if I run into cycle, into render the scene, you can see that those points are directly rendered as spheres in cycle, and this looks kind of clean. So if I run a little bit of animation, we're going to have that first scale happening. It is quite longer to render, to simulate, but this allows us to render everything. We can hide all of our modifiers. So can hide the fluid, the groups, push, question, scale, and I can hide my fall off if I want to. That simplify the viewport. But by default, everything is white. We don't have any color. So if I open a new tab, I can jump into geometry node, and you can see that this point cloud has a geometry node modifier applied. And this only has a mesh to point and a name attribute. So we do have attributes inside this point cloud. We can control it here inside our emitter into export. By default, we're in basic transfer property, but we can go into custom, and you can see all the properties that we can export into our point cloud. So by default, we already have color, rotation, and velocity. So I can keep it to basic. And if I select my point cloud, I can jump into data, attributes. You can see I have radius, color, velocity. I don't need more for this tutorial, but if you need more attributes, you can just select them inside the custom. If you want the scale, you can export the scale. If you want the ID, you can. If you want the group of your particle, you can too. So I will keep the basic, keep the scene lighter to render. And inside this this geometry node, I can add a set material, and I can create a new material for this simulation. I will call it grain, and set it inside my geometry node, so I can apply this material to every particle. And I can now jump into shader editor and work on this shader. So now if I grab my attributes node and I can grab my color attributes, and this is my gradient that I simulate. If you need to get the exact name of your attribute. So you have a capital C in color. You have to write it correctly, otherwise it won't work. I can control this color as I would do in any shader. This is why we choose to apply a grayscale to this simulation. So with the color ramp, I can actually control this gradient. And if I even add a map range, I can also add and blend here my gradient. I can control this gradient as much as I want. And I can transform this black to white to something that will look more like the render of here, some blue, can have some purple here, can invert it like this, and we can even add some different shades of it so we can have a nice gradient to it. So this is how we can get back our attributes inside geometry node and bring it back into our shader. So now with a little more tweaking, I added a camera and added some more lighting and developed this material a little bit. You can see I still have this base with my color attributes turn into a color ramp into the color of my painted grain. Some emission that I turned on, but you can I turned it off, but you can turn it on if you want with another map branch. Yeah, but it's not quite necessary, but you can. And the rest is more to define that background grain to have it like more random white to purple material. But yeah, basically this is it. So this is how we can recreate this type of animated grain. I hope you guys enjoyed this tutorial. Please subscribe to the channel if you would like to support me and don't miss the future tutorial that I will release. Thank you guys for watching and stay tuned.